Hello people. So in this second video of this series, here I'll solve the exercise 1.2 for Ncert Math class 9. In the previous video I solved the exercise 1 for this same textbook. So in this continuation, let us start with problem 1. So the problem 1, it's a true and false question. So it starts like problem 1 is every irrational number is a real number. So what do you think? Every irrational number is a real number. Now real number is made up of rational and irrational numbers. Rational and irrational numbers. So this statement is true because all irrational number falls under the domain of real number. So this is true. Second question is every point on the number line is in the form root m, where m is a natural number. So problem 2, what do you think? So we can write 5 as root 25, it is fine. We can write 10 as root over 100, it is fine. So all positive numbers we can write in the form of some root m. But the problem is with negative numbers. You can see that if we have minus 5, we cannot write as root 25. This is wrong. So this is a very what to say, no negative numbers can be written as root over some natural number. So this is not true when any number n is less than 0. So this statement is false. So 3, every real number is an irrational number. No, why? Every real number need not be an irrational number. Suppose I have 5, 6, 7, 8, so on. These are rational numbers. We know that it can be written in the form of p by q. So every real number is an irrational number is a false statement. Okay. So let's jump into problem 2. The problem 2 is, are the square roots of all positive integers irrational? If not, give an example of square root of a number that is a rational number. It's simple. Suppose I have 25. The square root of 25 is 5. So it is rational. Okay. Or you can say root 4, root 5 square, that is 25. Anything square, suppose root over 6 square, which is equal to root over 36. So this is also rational. So basically, you take any number, square it, and you take any number a, you square it, and then you can write it as a square, which is a. So that is already a rational number. So this is an example to show that the root over of positive numbers need not be irrational. It could be rational. And there are a lot of numbers where the root over of that number is irrational. For example, if we take root 2, it is an irrational number. It is like 1.414 and so on. So let's jump into problem 3. Show how root 5 can be represented on a number line. Well, this is a very interesting problem. So let us first draw a number line. We draw 1, 2, 3, 4, 5, and similarly we let us draw the y-axis also. This is x-axis, this is y-axis, just to make it complete. Now let us do some calculation. So we can write root 4 is 2, that we all know. Root 5 is root over 4 plus 1, which is equal to root over 2 square plus 1 square. I think you have guessed on which way I am going. Now what we do, we take a line. Let me draw with some other color. So we draw 2 units along x-axis and 1 unit along y. So let me draw the values. So this is 1, this is 2. Now this length from A to B, what it will be? It will be root 5, because we know from Pythagoras theorem AB square equal to 2 square plus 1 square. Now to draw it on a number line, what we do is that we take AB as the radius and draw a circle. I will draw a rough circle. Now the radius will be, as you move through a circle, the radius is fixed. So AB will equal to AC if we assume this to be the point C. So therefore AC will be root 5 unit. So let me do this once again in a freshly, so to make you understand. You are asked to draw root 5 in a number line. So what we do is that we wrote root 5 as 2 square plus 1 square. Now we took a triangle with base 2 and height 1, so that the hypotenuse length is root 5. Now with root 5 as radius, we draw a circle, and that circle will cut the number line at some point. Therefore this length will be root 5. That's it, as simple as that. Thanks for watching. If you like this content, feel free to drop a comment, like and share this video. If you want to support, you can subscribe to this channel. You are welcome. Thank you.